days holidays. 8 is. We'll put it in the group also.
Students. Students, we have sent the new link. Please click on that link, and also please inform to your friends also. Let them join back once again. Inform to your friends also. So we'll solve at least one problem so that this concept will be over. Only 2 people are there. Send a message, man.
I sent it. I sent it.
Accept once again. Please log in. I don't know how. Hmm?
16.
Okay, good. Students, please tell to your friends to click on the new link. Just now we have sent. So let us start. So the first question that what we'll take is from the exercise. Examples, you can see it yourself. So I'll take the exercise question. Most of the time, this thing was asked in the board exam. So this is the formula. And yesterday we have discussed when you can apply this. So I'll repeat once again, there are 4 conditions which should be satisfied. The first condition is n, number of trials should be a finite number. Right? It cannot be infinite, it should be a finite number. Next, the random experiment, whatever the game that you are considering, it is dichotomous in nature, means dual outcome, success or failure. You will convert the problem to success or failure kind of thing. The third thing, each trial should be independent of each other. Means here you have 60 questions. Now I have questions like 1, 2, 3, 4 like that. So you know that for each trial, what is the probability of success? 1 by 4. For this also same 1 by 4. For each question individually, the probability of success should remain same, and the trial should be independent of each other. So means whatever you have written here, this thing should not impact the probability here. So that's what it meant by trial should be independent of each other, and probability of success should remain same for each trial. These are the 4 conditions that needs to be satisfied. So let us take the question. The question is, I'll write also here for you people. One question, right? So no problem. I will. A die is thrown 6 times. A die is thrown 6 times. Is thrown 6 times. If getting an odd number is a success. Come on. What is the probability of? What is the probability of 1? 5 successes. 2. At least 5 successes. At least 5 successes. 3. At most 5 successes. At most 5 successes. Okay. So let us try to understand. Now I could do this problem without Bernoulli trials. Just try to imagine without Bernoulli's trials, if I try to do this, it will be very, very complex. The reason is a die is thrown 6 times. Try to imagine the sample space, how much you get. For one time, what is the sample space for die? 6. For 2 times, 6 square, that is 6. For 3 times, 6 cube. For 4 times, 6 to the power 4. For 5 times, 6 to the power 5. For 6 times, 6 to the power 6. It's a huge value. It's very difficult to visualize that sample space, right? So what Bernoulli has done is don't worry about 6 times. You just worry about 1 time. So one time if you take, what is the your sample space? Random experiment. Now it is a die is thrown. A die is thrown. Sorry, a die is thrown. Now, how many number of times? N. That you will call it as 6 times it is thrown. That you will call it as 6. N equals to 6. It is Bernoulli's trials. Let us check whether it is Bernoulli's trials or not. So there are 4 conditions. The 4 conditions are what? First, it should be n should be finite. So n is 6. It's a finite number. Satisfied. And then you need to make it dichotomous. Means what you are telling here is when you throw a die, you are defining your success. That is getting an odd number. Suppose if you get odd number, it is success. If you get other than odd number, that is even, that is failure. That's it. It is dichotomous now. So, second condition is satisfied. The third condition, the probability of success in each trial should remain same. Means what is the probability of success here? Let us calculate P. P. What is the success here? Getting an odd number. What is the and if you write the sample space for this, what do you get sample space? Your sample space is equals to 1, 2, 3, 4, 5, and 6. Now getting an odd number means 1, 3, 5. 3 are favorable for you. 3 out of 6. So P, probability of success. P is what? I'll write also in words. Probability of success. That is 3 by 6. That is 1 by 2. And this remains same for every trial. Yes or no? So third condition is satisfied. The fourth condition, the trial should be independent of each other. What does it mean? First time when I throw, suppose imagine I've got odd number. That will not impact what you get in the second trial. Yes or no? So that way trials also are independent. So all the 4 conditions are satisfied. Now what you do, you just take this. What is N? What is P? You just need these 2 values actually, N and P. If you know these 2 values, all other things you get it. What is Q? Q already have a relation. That is 1 minus P. That is 1 minus 1 by 2. That is 1 by 2. That is basically getting an even number. Not odd number means even number. So 1 by 2. Now you know P and Q. Write the formula now. So X values, you know. Tell me what is the X values now? Capital X values range from where to where? So you are throwing this 6 times, right? So means your random variable can take values 0, 1, 2, 3, 4, 5, at most 6, 0 to n. So what is your formula? P of, write this formula as it is. Capital X is equals to small x. In general, you write this n c x q to the power n minus x p to the power x. Now you know n, p, q values. So substitute those values. So what is n? N is 6. 6 c x. What is q? Q is 1 by 2. 1 by 2 whole to the power 6 minus x. That is n minus x. P. P is what? 1 by 2 whole to the power x. Now if you simplify this, it's because here 1 by 2 base is same. So you can add these 2 things. What do you get? 6cx 1 by 2 whole to the power 6 minus x plus x. Minus x plus x gets cancelled. So what you get here is 6cx 1 by 2 whole to the power 6. That is your probability of x equals to x in general. You simplified this. Now let us try to answer one by one. Generally in the exam they give 3 parts. Okay, up to here if you do this much for writing this formula you will get 1 mark, and for identifying the values here you will get another 1 marks, so 2 marks. The remaining 3 marks, one for each correct answer. You have to substitute these values in the formula and get a correct answer. For that you will get 3 marks. So let us do first one. 5 successes means what? Your x value is 5, exactly 5. So in place of this, in place of x, you have to put 5. The first one, I'll write it here. The first one is probability of getting 5 successes. That is capital X is equals to 5. So your number of successes is 5. That's what it is. X value ranging 0 to 6. So now just substitute this. So what is the formula? We have simplified already. 6cx 1 by 2 whole to the power 6. 6cx is what? 5. 1 by 2 whole to the power 6. So what is 6c5? nc n minus 1. You remember there is a identity. You will get 6. If you want to calculate 6 1 by 2 to the power 6. 6 into 1 by 2 to the power 6 is what? 64. That is 3, 2, 2 threes, 2 threes, 2 32s, 3 by 32. So you know NCR formula, right? You can use that formula in case if you don't remember. 6C5. So you want me to write the formula? General formula? NCR. People have forgotten, please recollect. NCR is n factorial divided by n minus r factorial into r factorial, right? Remember this. So 6c5 is 6 factorial divided by 6 minus 5, 1 factorial and 5 factorial. So 5 up to 5 factorial gets cancelled. This 1 factorial. So we'll get 6. 6 by 1, 6. Clear? Now the second one. What is second one? At least 5 successes. You need to be paying attention to this. In random variable also we have seen. At least means what? Your random variable should be greater than or equals to. Whenever you use the word at least, it is a symbol. Greater than or equals to 5. Now you tell me what you will get. Greater than or equals to 5 means 5 and also 6. So you will write this thing like this. Probability of x equals to 5 plus probability of x equals to 6. That's it. 5 and 6. Now, this you already have calculated. You can just take this value if you want, or simply put once again here. 6c5, x is 5, 1 by 2 whole to the power 6 plus 6c6, x is 6 now, 1 by 2 whole to the power 6. So if you take 1 by 2 whole to the power 6 common, you get 6c5 plus 6c6, that is 1 by 2 to the power 6 into 6c5 is 6, 6c6 is 1, that is 7 divided by 6 plus 1 7 by 64, that is second. You will get another 1 mark, 1 mark for this, 1 mark for this. Now the last, at most 5 successes. Oh, once again it is buffering. No. Okay, let's hope. Let me finish this. Afterwards, if it buffers also, okay, at least we have explained the concept and we have done at least one problem. Let's hope I'll finish this. At most, probability of X at most means less than or equals to 5. Okay. Probability of X less than or equals to 5. So less than or equals to 5 means what? So it can be 0, 1, 2, 3, 4, 5. Up to 5. Right? So smart way of doing it is you could have done this like this. That is, okay, let me write this for you. Probability of less than or equals to 5 means X equals to 0 plus probability of X equals to 1 plus probability of X equals to 2 plus probability of X equals to 3 plus probability of X equals to 4 plus probability of X equals to 5. So basically in place of X you put here 61, sorry, 60, here is 0, 60, 61, 62, 63, 64, 65. So you can get that sum of, and what, there is one smart way if you remember. What is the sum? This is basically a random variable. What is, you remember in the random variable probability distribution, sum of all its probabilities is what? 1. Sum of this we can write it in a smart way. Sum of all the probabilities, that is 0 to 6, is 1. So what you wanted is you have to remove this one. From 1 you have to remove 6. Then you get the answer. Easy thing for this is 1 minus probability of X equals to 6. Equivalently you can write like this kind of techniques you can use. That is, instead of writing 5 times this one, 6 times this one, you can write like this. That is 1 minus probability of X equals to 6. That is 6c6 1 by 2 whole to the power 6. That is 1 minus 1 by 64. That is 64 minus 1 divided by 64. That is 63 by 64. 63 by 64. That's it. So you will get another 1 mark. So this is a 5 marks question in board. Most of the time this question was asked. Now if this we'll do this class until the line is good, the internet connection is good. In case if it gets any problem, it's okay. We are done with the concept. We are done with one problem. Now what I will do is I will try to do this year board problem. What problem that they have asked this year? Let us see. Please take down this, all of you. You may take down. And if you have any doubt, you can ask me in the chat in case if you have any doubt here, so that I can repeat. Yeah. Yeah, I'll go this side. Okay. So I'll write the question here. At least a question I can erase. I'll go. The board question I will write. This year 2020 question. People who have already done, you may write down this and also please solve it. A person, this is also textbook question. In the textbook, the question number exercise 13.5. The question number 10. The question number 10 as it is. A person buys a lottery ticket. This is BU board and 5, 10th question. A person buys a lottery ticket. A lottery ticket. In 50 lotteries. In 50 lotteries, comma, in of which in each of which his chance of winning a prize, his chance of winning a prize is 1 by 100, is 1 by 100, full stop. What is the probability that what is the probability that he will win a prize, that he will win a prize. A, exactly once. Exactly once. B, at least once. At least once. Okay? Please try to do it. Yes. I hope everybody has written this. So this is the 5 marks question. And generally question number 48. Sir, this concept can be applied in cricket match also, sir. Explain it, sir. Yeah, you can say like this. If you want to apply it cricket match, think does it satisfy the conditions? What is the condition that it should satisfy? First condition it will satisfy. That is win or lose. You can say win, you can consider it as success, losing failure. Look at the second concept. The probability that somebody is winning. It's like if you say that India wins in every match, is it same? Probability that India wins every match, is it same? No. You cannot say that, right? If a probability of India winning in every match is same, then you can consider. N is number of matches. That always you can make it 10 matches, 20 matches like that. But the probability of one team winning in every match may not be the same. Because of that, it does not satisfy Bernoulli's trials. Okay? Because there are a lot of factors include. Every team has got which players are playing, and then sometimes depending on the pitch, so many other factors are there. So it will not satisfy Bernoulli's trials. So it's buffering. Okay, now it's okay. Fine. Let's try to do this. A person buys a lottery ticket in 50 lotteries. Means what? N is 50. In each of which his chance of winning a prize is 1 by 100. They have already given P. consider winning is success. So P is given. What is P? 1 by 100. What is Q? What is Q? 1 minus P. That is 1 minus 1 by 100 means 100 minus 1, 99 by 100. So, what does it mean? Probability, if you buy 100 tickets, you may get one ticket which is winning thing. That's the meaning of that. The probability of winning is 1 by 100. Failure, there is a lot of chance. But what he has done, he buys 50 lottery ticket in 50 lotteries he has bought. What is the probability that he will win a prize exactly once? Now, you need to tell exactly once means probability of x equals to 1. So, because please write this formula. At least you will get 1 mark writing the formula correctly. Probability of x equals to x. X equals to x, that is NCx q to the power n minus x p to the power x. So here I can substitute the values also. What is n? N is what? 50. 50 cx. What is q? Q is 99 by 100. 99 by 100. Whole to the power n minus x. N is what? 50. 50 minus x into p. P is what? 1 by 100. 1 by 100 whole to the power x. So n x small x value. What is the x value it can take here? 0 to 50. 0, 1, 2, 3 up to 50. So here x equals to 1. Exactly once means only once is winning. That is n is 50. C x is 1. 50 C 1. Then q. Q is what? 99 by 100. 99 by 100. 50 minus 1. That is 49 into P, that is 1 by 100 whole to the power 1. So you don't need to write that. Okay, if you write also, this is what you get. So what you get here is 50 C1, that is 50. 99 into 99 whole to the power 49 divided by this one. Here 100 to the power whole to the power 49. Here it is 100. That is 100 whole to the power 50. You don't try to simplify this. You can leave it this because it is a very big number. Okay. I don't know whether your calculator gives you value for this. You don't need to simplify. You can leave it here. One more way is the same. You could have done is 50, this 50 you could have cancelled like this. Okay. This is also perfectly fine. Another way, this 100, this 50 you can cancel. So what you get? 50 into 99 by 100 whole to the power 49 into 1 by 100. So 50 ones, 50 twos. So that is 1 by 2, 99 divided by 100 whole to the power 49. Now, second question. At least once. See here. At least once means what? One or more. One or more means here 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 50. Do you do that? You don't do. So, what you do? X greater than or equals to once is nothing but 1 minus probability of x equals to 0. Have you understood this? So you have got 0 to 50 like this. 0 to 50. So sum of all these things is 1. Sum of all these probabilities. Now for 50. X greater than or equals to 50. That is nothing but 1 minus 0. 0 if it goes here, 0. That is probability of x equals to 0. 1 minus probability of x equals to 0. This is how you write. This is smart way. So now 1 minus probability of x equals to 0. That is 50 C0. 50 C0. That is Q. 99 by 100 whole to the power 50 minus 0, 50, and 1 by 100 whole to the power 0 becomes 1. That is nothing but 1 minus 50 0 is 1. That is 99 by 100 whole to the power 50. You also want to write this. Here you will get, yeah, you can leave it like this. So you will get 5 marks for this. Okay. Now it's already 12:10. So I can see for many people it is buffering. No, it's not buffering. See there. Okay. Can we do one CET problem? Or um, one we will do something called defective and not defective. In CET also it was asked many times. Okay, let me solve CET question only. One CET question. CET. Okay, fine. Good. Hmm?
Speed.
CET. Yes. Yeah, CET question. I'm going to uh, do CET question. Hmm?
Sir,
Hmm?
you can announce for the test again.
Okay. Regarding the test, you will have the test on Sunday. Sunday you'll have the test physics, chemistry, and maths on learnerstest.org, our assessment platform. Please, all of you, ensure that you have access to that. You just need email ID. If you have got any problem in registering there, you can contact your mentors. They will help you. So, probability question, let me take it. Okay, take this CET 2018. I'll write also here a flashlight. All of you know what is flashlight? I'll keep this if somebody is writing this. A flashlight has 10 batteries. CET 2018. A flashlight a flashlight has 10 batteries. Has 10 batteries. Out of which 4 are dead. Out of which 4 are dead. So, if 3 batteries are selected, if three batteries are selected without replacement, without without replacement, untested, untested, then the probability that then the probability that all three are dead, all three are dead is options. Let us see who can do this correctly. Options are A 1 by 30, B 2 by 8. Why it is 2 by 8? Should have been 1 by 4. Okay, C 1 by 15, D 1 by 10. So here understanding the problem and identifying what is N, what is P, what is N and P. Only two things you have to identify correctly. Then all other things you will get it. So can somebody tell what is N here? Anybody? Please type it there. What is N? Yes. 10. 10. Many people are telling 10. No. N here is number of trials. Selecting. Here, three batteries are selected without replacement. Okay. So these are your tries. 3. N is 3 here, not 10. N is 3. This is the trial what you are doing. But this is a given fact. A flashlight has 10 batteries. So you think of there are 10 batteries, out of which 4 are dead. If 3 batteries are selected without replacement and tested, then the probability that all the 3 are dead. Now your success could be, you can think of your success is getting dead ball or dead battery is success. Your success P. What is the probability of getting? That is out of 10, 4 are dead. That is 4 by 10. That comes to 2 twos, 2 fives. 2 by 5. P is 2 by 5. And what is Q? 1 minus P. That is 1 minus 2 by 5. That comes to 3 by 5. This P and Q. Now, what is, you see, this 10 and 4 are used to calculate P. Don't get confused that with N. N is basically trials. Now, think of there are 10 batteries here as a heap of 10 batteries. So, like this, okay? So, out of these 10 batteries, 4 are dead. Out of 10, 4 are dead. We don't know which one. Now, in this, you are going and picking. Okay, how many you picked? 3 batteries you have picked. What is the probability that all the 3 are getting dead ones? That is the question. So, N is 3, N trial, 3 trials, and probability of getting dead ball, it is 2 by 5, not getting, that is 3 by 5. Now, question is, what is the probability that you get all 3, so 3, capital X. Your dead balls could be what, how many? If 3 batteries are selected, 3, maximum 3 actually. Okay? Yes or no? So what is the probability that all the three are dead? That is n is 3, 3c 3, nc x. Q 3 by 5 whole to the power 3 minus 3 0. Then Q is what? 3 by, sorry, P 2 by 5 whole to the power x, that is 3. So this is 1, this is also 1. So it is 2q divided by 5q. That is 2 cube is 8, 5 cube 125.
So this question you can't use binaries.
Yes, I made a mistake here. We cannot use Bernoulli's trials. So here the word is without replacement. So okay, I'll change the question here. So please make a small change here. I did not notice this because there are no options here with this. With replacement. If it is with replacement, you can apply Bernoulli's trials. But the question here is without replacement. When it is without replacement, every time probability is changing. For every trial, the probability is changing. That's why you cannot use Bernoulli's trials. But I just made a small change here. With replacement, you do it. Now I will do without replacement. Okay. Now this thing is suitable for with replacement. Now, actually in the exam it was without only. So now without I cannot use. What I should do? So probability of getting all three dead, all or three dead batteries, three dead batteries. Now I'll use multiplication theorem here. What is the multiplication theorem? So first time what is the probability that you get? It is dead. There are 4 dead balls out of 10. That is first time. Second time it will be 3 out of 9. Third time it will be 2 out of 8. Now we simplify this. That is 3 ones, 3 threes, 4 ones, 4 twos, 2 2 gets cancelled. 1 by 30, 10 into 3. So the answer is 1 by 30. Okay. Here this keyword makes a difference. With replacement, it is Bernoulli's trials. So here I'll put without and with. So you have to be careful. So with means this is the thing. Without means this is the thing. Okay, good. This is a good question. It's good that we have Bernoulli's trials when not to apply. If this is with replacement, I could have applied this. Without replacement, I cannot apply Bernoulli's trials. So I am applying multiplication theorem. Okay, sorry. In a hurry, I picked this question. I should have seen that it's a multiplication theorem. But yes, we saw that we changed it so that we can apply even Bernoulli's trials.
Then three letters are there. If three letters are there, of picking which number? See, all others are there.
Okay, let us take this one. This CET, twice it was asked, CET 2014 and CET 2017. Here it is with replacement. So you can apply Bernoulli's trials. Here it is, a box has 100 pens. A box has a box has box has CET 2014 and 2017. A box has 100 pens, 100 pens, of which 10 are defective, of which 10 are defective. The probability that the probability that the probability that the probability that out of a sample of 5 pen, out of a sample out of a sample of 5 pens drawn one by one, drawn one by one with replacement. Look at this word very careful. With or without replacement. If it is with replacement, you can apply Bernoulli's trials. Without replacement, you cannot apply. With replacement. And at most, here it is at most one is defective. At most one is defective is. Please try to answer. Here the options are A 9 by 10. Please 9 by 10. B 1 by 2, 9 by 10 whole to the power 4. C 9 by 10 whole to the power 5 plus 1 by 2, 9 by 10 whole to the power 4. D 1 by 2, 9 by 10 whole to the power 5. I don't see any difference between your CET and board exam. Same question, same thing. Only thing is your steps are not required. Only one they are asking. They 3 are asking. So here also you have to understand the question. A box has 100 pens, out of which 10 are defective. This is not N. Please understand. The N is the probability that out of a sample of 5 pens, out of a sample of 5 pens drawn one by one. So this is your N. You are doing. So you see, you have to imagine that there is a box. Okay, in this box you have got 100 pens. In 100 pens, 10 are defective. 10 are defective. Now you are just checking samples. You cannot check everything, no? You just go and check. You check 5 samples. Sample of 5 pens drawn one by one. One by one you are picking. And you are putting it back once again with replacement here. You pick one and then put it back. What is the probability that you get at most one is defective? That is probability of X at most means less than or equals to 1. That is probability of X equals to 0 less than 1 means. So now you know what is N. N and P. Let us calculate N. N is what? 5. Because 5 samples you are taking. And what is P? So here success can be getting a defective one. So what is the getting defective one? 10 defective out of 100. 10 by 100. That is 1 by 10. So automatically Q will be 1 minus 1 by 10. That is 9 by 10. So substitute. N is 5, C 0, Q. Q is 9 by 10 whole to the power 5. First term. So P to the power 0, 1. Next 5C1, 9 by 10 whole to the power 4 into 1 by 10. That is P to the power, P is 1 by 10 whole to the power 1. So if you simplify 5C0 is 1. That is 9 by 10 whole to the power 5 5. So 1 by 10, 5 twos. So I can write 1 by 2. 9 by 10 whole to the power 4. So what is the option? Option C. Some people have already given correct answer. So option C. So I think 12:30 will stop here. Enough. We have done 2 CET problems, 2 board problems. The homework is please solve all examples and also exercise problems. In case if you are not able to anything, any of these probability questions till now, tomorrow you can clarify from me. Okay? Then I am planning to start a new chapter tomorrow. Very, very easy chapter. Okay? Thank you. Yeah.